Some of 4, 2. Let's start with 2 then. So if 1 was fine, we'll start with 2. So 1 double works. B. Yeah. Okay.
These sneaky molecules.
So this should be what you got, okay, for the NMRs. So to start with, B was hard. I know B was hard, and a lot of people were having a hard time with B. You need to remember first, though, to do your IHD, and the minute you see an IHD of 1, you guys are automatically at double bonds. You've got to remember about your rings, okay, because that's where trouble comes. I'm sure you all came into this in the end, but I'm here to remind you. Don't forget, rings are also a valid IHD, right? A ring or a double bond. The second thing about this is the symmetry in the system, which I recognize because I have really only 2 unique environments and lots of hydrogens, right? So that really speaks to symmetry to me. I can't have a 2-part symmetry, though, right? Because a 2-part symmetry, I wouldn't have a peak that would have 9 hydrogens, right? So it had to be a 3-part symmetry. Does everyone know what I mean about that? Okay, so there was 1 peak on here that had 9 hydrogens, right? If you looked at the NMR for that B, you had 1 that had 9 hydrogens. This actually was a doublet, but it's very hard to see. And then there was a quartet, which I've spread out a little bit. This one was a little bit easier to see, though, because you can see the differences in heights. But my point is that if there's symmetry, which you know there has to be, because there's only 2 unique environments and 12 hydrogens, right? So it's a lot. You can't have a 2-part symmetry. Because a 2-part symmetry would say, in essence, I have 4.5 protons here and 1.5 protons here. I can't have a half proton. So it has to be a 3-part symmetry, right? That's just using logic. And so that's telling me then that I have 3 hydrogens here and 1 hydrogen in each symmetric unit, which is how you would have wound up at this. Okay? So when you came and did the mechanism...